And I think for the very first time, well, it's not that I think, I know now, we are able to put all the different things that the players are looking for. It's like, so they're looking for a textured surface and one that doesn't wear out after a couple of months. You know, the sprayed on ones tend to wear out fairly quick. They want the texture to last a long time and perform. And then they want durable paddles. They want the feel. They want the sound and all of these things to be incorporated into their paddle. But they also want tons of power, tons of control, huge sweet spots, and the ability to shape the ball beyond physics, right? So we're like, okay.
Beyond physics.
Yeah. So we're like, okay, that's our goal, right? So started working on it. We've created this is a textured cure ply now. So this is actually cured. So we can now make the surfaces, you know, a certain way to texture it, not texture it. And then we created a method to bond this to a soft core, which is our rib structure, before going into the mold. And then we use pre-cured and soft plies to bond, to create. I'll give you a little sneak peek into our paddle, but we're able to now put that textured surface right onto a molded paddle. So now that textured surface goes into it, we're able to mold it and create this just awesome. And to be quite honest now, so we said, okay, people want a fast paddle. So we created a power and a control. So they have a choice. But in addition to that, they're saying, well, I want to be able to really shape the ball. So what we did with the core on both of these is we made the core so it actually absorbs, and the ball sort of sinks into the face, but also the paddle flexes back and it shapes around the ball, and then it slings it, or almost like a slingshot or a trampoline. You know, trampoline, I think that's probably the most common word being used today. But it's occurring with the entire structure. So it's flexing from the throat area, it's bending back, it's sort of cupping around, and then it throws the ball back. And we're doing that, and we also lowered the frequency. So now there's the control aspect is in there. So you have very easy dinking. We've increased the size of the sweet spot on the paddle. So, I mean, literally you can bounce a ball almost all the way to the edge of the frame, and you have that forgiveness, or that, you know, that dwell time that goes into the ball. So expanding the sweet spot makes a very forgiving paddle. It's at 8 ounces, and people generally, when you have a light paddle and you hit the ball off center, it tends to twist very easy. But because this one absorbs the ball, it doesn't twist in your hand. So we can keep a very neutral 8-ounce paddle with a very light rotational weight, and gives you very quick hands and tons of stability.
That's caused by what you were talking about with that carbon fiber, like it more pliable, like this, like front and back, but it's not like twisty, right?
Yes, correct. And then the actual face is more forgiving, so the ball travels deeper. One of the things you know, people notice when you hit a ball, there's a ball mark that's left on the. You're going to notice with these paddles, the ball mark diameter is actually going to be larger. And it's not that you're compressing the ball more or you're not flattening the ball. What's actually happening, the ball's traveling deeper into this paddle. So you have more surface to surface contact with the ball. So the paddle is sort of wrapping around the ball, and then it releases. So by having more of that surface to surface contact, you're able to keep the ball a little longer on your paddle. Because you have more of the ball going in, it grabs it, and then you can actually spin it more. So that's the shaping of the ball. And the energy that it returns, we did it in 2 ways. So one, we have the power, and then we have the control. With the control, the energy coming in from the ball and then the impact, we keep more of that in the paddle. It doesn't go back into the ball. Where on the control or on the power, we push more of that energy back into the ball. So then you'll see this as the ball exits our power paddle, it's coming off hot versus the other one. The other one, you're going to have to generate more of the power yourself, where this one you could keep actually a shorter stroke and generate plenty of power with it.
What's behind the technology?
It's the way we built the core. So
yeah, you talked a little bit about that rib structure before. If you could kind of explain it like
I don't know
I'm
if
an
the
8-year-old.
camera would pick some of this up, but there's some writing on these. So this one says 30 degrees. So this is a 30-degree ply. FAW is the fiber aerial weight or the density for a certain area for a square meter. This is 0 degree, 19 degree. This 19 degree is fairly stiff. You see that? Where a 30 degree, same material, just different angles, very soft. And then we have 0 degree. Well, I kind of broke this one up, but this is very stiff. I mean, so this guy will, but it's all the same, and it's, T700 at 0 degrees, 19 degrees, and 30 degrees. And I think I even have I had a 45. So by changing the fiber angle, you can change how stiff the bending, or you can make it more flexible, or you can make it stiffer so there's more resistance. But also if this one's 30 degrees, it's softer, but when I go to twist it, it's going to be stiffer when I twist it, because you have a positive and negative, so it's going to take more force to twist. Where the 0, I can twist and essentially just, there's no fiber in between. This is just being held by resin. So most of this structure, its strength is at 0 degrees this way. So this is very, very stiff. That is one way by changing our rib structure inside. So we have ribs that run the length. That is how we begin to either absorb energy and keep it in the paddle or return it. One of the cool things that we did with this, and you'll see some drawings or graphics, so our rib structure runs from the top down to the bottom of the paddle. Well, on this particular one, we broke it up into 7 sections. So rather than being one single core, we have 7 microcores within the core of the paddle. So what that does is, by creating these sections, now there's no structure in between the sections. So that makes, that allows, for more movement, and it allows for more reaction, but the compression is still there. So we allowed the whole structure to move back and flex and sort of shape. And that's where, that is how these cores are much different. And that's what's really cool about carbon fiber. You cannot do that with polypropylene. Plastic is just the piece of plastic. I mean, it's like a straw, right? There's very little structure to it. It's heavy. This thing is just, it's super light, but it's extremely strong. Like, you can hang a semi-truck off of this piece, and the tensile strength of it is just tremendous. Carbon fiber and utilized in the right way, you can make just some amazing structures, and that's really my specialty, right? So that's where we can get into these really cool structures and create these systems that are very efficient in absorbing energy or returning energy and feel. And then we created some dampening materials in there that that help us with that perception of feel, right? So that's connected to sound, it's connected to the vibration in your hand and how the ball sort of jumps off the face. So for the very first time, and I think in pickleball in general, and there isn't a paddle that even comes close in terms of technology and design and everything. And this one nailed it on all of those aspects. And I think this is the beginning of a new generation of pickleball paddles that will be, for sure, I think Gearbox will lead that, because we have patents on all this, so not anybody can just come in and copy. So we've I have a patent now that's been our solid span technology patent. I think it was issued probably 3-4 years ago. It took about 2 years to get it through the examiner and all that. So And now I've just applied for like 16 new patents. This particular paddle has 3 of the new ones, and then some new proprietary things that we did. So you're going to see, I think, the evolution of feel and performance and shape and all that. That is just going to get better from here forward. Yeah.
Something before we get into patents, because I think that's definitely a very interesting aspect, especially given if you look at a lot of the top paddles, you start to see that they're somewhat redundant. The only thing that's changing is probably branding and marketing. Before we get into that, a popular question that you probably get with any paddle, especially these days, is like edgeless. Is that edgeless?
Yes. And the majority of our paddles are edgeless. And what edgeless really means that it goes into a mold, which is a cavity mold. So and then we blow it up internally like a balloon, like you would push all the material to the edges of the mold.
What is that material? So it might make more sense to other people. Like I saw that, like you have the rib structures and you have that, it's not hollow, but there's like that material that we like.
Yeah,
kind of
there's different, well, some of it we can use, for dampening. We can use a rubber type material. For expansion, there's actually this right here. This is, I won't tell you exactly what it is, but it's a chemical process that expands when it reaches a certain temperature. So at about 100 degrees Fahrenheit, it will begin to expand. So this piece, I'll show it a little closer here, is the handle of but this isn't the outside. I mean, this is a pre-shape of our handle. So then what we do with this is we begin to wrap the carbon fiber around this. And then this piece, when we shape this at a lower temperature, and then once we're ready to mold it, we fire it up at a much higher temperature, and then this will expand again. So this could expand maybe 2 or 3 times, and it'll expand probably, depending on the material, up to 30 times its original shape. So, and by doing that, we can create tremendous pressure internally, and that helps push the material. That is one way. So this is what we call doing it through a chemical process. We could also use a gas. So once if we had like a bladder, and we wanted a sealed system, so then I would put a gas in here, and then when we put that in the mold, the gas would just expand, right, and push everything to the sides. Or we could put an air nozzle in the mold, and then with a bladder as well, then with a compressor or just external air pressure, we can pressurize the inside of the paddle. So there's several ways to create this internal pressure. This is one of them. This material here, it's not structural. So, there's no structure to this. This is, yeah. So this, you can see it's not structural. But this helps us shape. It gives us what we call a pre-shape, so we can form the carbon fiber around it. Our goal is to form this paddle almost to the perfect dimension to fit inside the cavity mold, because you don't want it to be small and then expand and stretch, or too big and then you compress it, because you get wrinkles and all that. Wrinkles in carbon fiber are a no-no. And then if you don't have enough, so the mold or the part going into the mold has to match almost perfectly. Otherwise you get air bubbles, you get, areas that don't blow up properly. And anytime you do that, you compromise your structure a little. So there's a trick to doing what we call the pre-shape to match it almost perfect to go into the mold. You want to just be able to put this piece into the mold and just fire it up and just pressurize the heck out of it. So your part, once it's cured, it's perfect. And so we do that again with air. We can do it with this expanding foams. We can add other materials in there. So I can actually embed dampening materials within this piece. I can do all kinds of stuff, and that's what's really cool. So with the combination of, and it's also, feel the weight of that.
Yeah.
It's
ridiculous.
there's no weight.
It's like feels like a piece of popcorn.
Yeah, it's like popcorn, but it creates tremendous pressure. So, you take that compared to polypropylene, which is a plastic that's extremely heavy. I mean, it's structurally, they're just, we're in two different worlds, and again, polypropylene and honeycomb paddles have their place. But now that we've actually matched the sound, the feel, the things with carbon fiber and some of these other techniques, we're going to push pickleball to other, and pickleball paddle technology to other realms. And then you get an athlete that can really maximize the performance of this. So now this paddle right now is at 8 ounces, but I could literally make this paddle extremely strong, probably 6 ounces. Yeah. Is the 6 ounce paddle something viable today? Probably not, because it's not. Somebody needs to learn how to use a 6 ounce paddle, and then how do we do things. I don't know where the game, but we have that capability. We can obviously make a 6, maybe even a lighter paddle. We can make a heavier paddle with the same strength and have just these tremendous. So I don't know where the industry will go in terms of the athlete, but we have quite a huge range to build a lot of things, So now we have this paddle, the Pro paddle, the Pro Power, that can generate at 8 ounces the same velocity of a paddle that weighs 9.5 ounces. So now you've got the maneuverability of this very light paddle, super quick, with power at your hands, when you need it, and just tons of control. You don't need a lot of mass behind it. The paddle's not going to twist on you. It's not going to get pushed back because somebody hit the ball hard. It'll actually return the energy. So now, how does that change somebody's game? So one of my goals with this was, if you needed more power, you don't need to go for a large swing. So you can just come here, and now you're ready. You just pop that ball back to your opponent pretty hard, and you didn't really move. So you're in the ready position to receive their shot, if they returned it, right? But so how do we shorten the stroke? How do we keep you in a more ready position most of the time? And that's really what all of these things are going into the design of this paddle.